So without further delay, let us start with session number 4. To chair the session, I request Shri Varindra Dhawan sir, HCD Operations Sale. Please take your seat on the dais, sir. And as the rapporteur for the session, I invite Shri Yogesh Sastry sir, CGM BRM BSP Sale. I request all the speakers to take their seats on the dais. Mr. Praveen Chaturvedi, Senior Vice President, Tenova Technologies. Mr. Padam Pal, Chief of Blast Furnaces, Tata Steel. Mr. Rajesh Ghosh, AGM TRL Krosaki. Mr. Harsh Chaudhary, Co-founder and CEO, Centra World. Mr. Satyaki Das Gupta, General Manager, Proposal and Technical Sales, Primetals Technologies. Mr. Kaushik Das Gupta, RHI Magnesita. I once again welcome all of you, sir. And without any further delay, let us start with the first presentation by Mr. Praveen Chaturvedi, Senior Vice President, Tenova Technologies Private Limited.
We'll directly jump to the presentation. Thanks all of you for giving this opportunity to present our technology. And as you can see here, I have mentioned the word iBlue. iBlue is basically green iron making. So this is the concept what we are now focusing on. Yeah, I will skip these slides. We are part of the Techin group, and basically you will see that there are Tenaris and Ternium, and we are one of the top 15 steel producers. You will find our Techin group in the end. So we are also a steel producer just like SAIL. More importantly, that we are also sustainability champion as declared by World Steel Association. So whatever products we are coming to the market, you can see our Tenaris and Ternium, our sister company, they are already featured in that one. And so yeah, this is the topic since we are discussing about the sustainability. So this is all our solution products related to metal and mining. We are in this field, and sustainability is a new mantra which has been given to us by our management, so that whatever we give to our client and customer, it should be related to the sustainability, whether it is a product solution or any advices. So this is about the technology DRI. We are basically DRI route steel making, electric arc furnace, and then we are into the reheating furnaces and cold rolling mill and all. This is about product portfolio. Just I will jump to the main topic, that is we are moving from you can see on the top carbon towards the hydrogen. In between there are various stages like carbon capture, storage, utilization, then switching over to natural gas, syngas, biogas and all. And then finally we have to go with the renewable based green hydrogen, which we have already discussed in the previous sessions. Now you can see here there is a one technology called energy iron. I am starting with this DRI making route. Since from the morning we have been discussing about the blast furnace, but this is an alternate route through which we can make the steel, that is the DRI. And more importantly, this DRI is, there is already selective removal of CO2 system. So when we say that carbon, CCU and CCS, that is already in installation, and that is nothing new for the DRI plant. And that is one aspect. Second aspect is that flexibility. You will see that any reducing gas, whether it is natural gas or cocoa and syn gas, reformed gas, whatever reducing gas which has the carbon monoxide and hydrogen, mainly the hydrogen, even the green hydrogen, we are very much comfortable, and our system doesn't need any change in the process, any change in the equipment. Whatever is available, we can plug and serve and make the steel out of it. And you can see in the end the DRI quality, we produce DRI from 1.5 to 5% carbon. 5% carbon, it is just replacement to the hot metal which we are getting from the blast furnace, around more than 4%. And whatever carbon we get is in an iron carbide form. So this is basically the scheme of our Energeron DRI making. The aim is to reduce the carbon footprint. Yes, when we switch over from natural gas to hydrogen, of course there will be the reduction in the carbon intensity. The most important thing what we have been discussing that yes, people are trying for in the blast furnace and other areas, how to capture and utilize. That is nothing new for us. We have been doing since 1957. Already you will find there is one plant in JSW Salao in India, supplied by us HOL DRI, Tenova. They are making the dry ice. The plant was installed in 1992, and since then they are making this. They are capturing the CO2. And 60% of the CO2 is getting captured. That is around 250 kg of CO2 per ton of DRI, and they are selling it to the off-taking companies like Air Liquid for making the dry ice. At other places they are using for food and beverage industries. Somewhere they are using for enhanced oil recovery also. So there are various applications nowadays. People are talking about using for methanol. In methanol, there are various companies, they will use this CO2 and add hydrogen and make the various useful products. So anyway, that is another part. Now, after telling you about our energy RN, that is our HOL based DRI technology, we make high carbon DRI. One route is either to melt into electric arc furnace. This is a conventional route, melt the DRI into the electric arc furnace and make the steel. But what is more important is that when we say that BF route is emitting lot of emission, so it is not the fault of BOF, it is only due to on account of the blast furnace. So if we can substitute the blast furnace with an alternative technology and retain the BOF in the downstream, and that is where our I-blue concept comes. Here you will see there is one word mentioned, OSBF, open slash bath furnace, in which we are melting the high carbon DRI which is coming from our shaft. And that 4% high carbon DRI, we are melting it, removing the slag and making the pig iron exactly similar to that of the blast furnace. And here we are retaining one aspect, one concept will be to retain the existing BOF LD converters. Otherwise one can use into the flexi modular furnace, or it can be converted into pig iron and sold into the market. So about the DRI, electric arc furnace, of course there will be 50% reduction on the carbon footprint. So that is also nothing new. Here you will see this is one plant in which this is around 300 ton electric arc furnace, in which they are putting the DRI, hot DRI, 2 DRI feeding point, and basically it works in an oxidizing mode. This is a conventional 100% hot DRI and hot means HBI DRI. And in Algeria already we have commissioned this plant in 2018 one, and second one also we have commissioned in a few months back for the second DRI plant. This is electric arc furnace based. Then these are some of the references. I'll just skip because this is well known that melting the DRI into electric arc furnace. Now I'm coming to the other aspect, that is replacing the blast furnace. How we can replace the blast furnace? Existing route you can see using the pellet, BF grade pellet. The challenge which we were discussing in the morning, that yes, how do we can replace the BF grade pellets? How we can utilize the BF grade pellet? It doesn't mean that if you are having the BF grade pellet, it is not mandatory that you should use blast furnace. We can also put into the DRI, high carbon DRI. We can melt it and make in the pig iron. So these are some of the schemes which is already implemented. I'll just skip. This is what we say I-blue, hot metal wire open slash bath furnace. By look and appearance, it appears as if it is a submerged arc furnace, and here we are using basically the blast furnace grade here. We are not demanding for the DR grade pallet. So whatever can is there, we are removing in the OSBF. As I told you, it doesn't work in some smelting mode. It works in a brush arc mode rather than in submerged arc mode. So these are some of the key features, technical aspects which is already in implementation. You can see there are two OSBF systems which are installed just beneath the DRI and making the hot metal and pouring into the torpedo daylight, and it is going into the BOF. So this type of concept is nothing new. Already it has been in practice in many places. BlackRock in Canada already they are using it, making the greenest pig iron. And the open slash bath furnace is nothing new, melting the DRI, because the same concept is being used for the mineral wool and other places. And in the downstream, if you are having the BOF, or else we can go with the flexi modular furnace which has been installed in the in GSP Raigad, in which electric arc furnace has flexibility to work with high hot metal. So in conclusion, you can see that yes, with the high grade pallet we can use it. And if you can give me sir 1 minute, I can show you the video what I have told, And yes, this is about our burning passion, that is sustainability. It should come from our heart, not from mind or by calculating other aspects. So this is what we say. Yeah, one minute video if I can share, then I think everything can be summarized. Thank you.
Reducing CO2 emissions. Direct reduction, a proven process with decades of history for the production of high carbon DRI, and the arc furnace, the preferred technology for low emission hot metal production, are now combined into one integrated new process, IBLU. Iron ore pellets, either BF or DR grade, are progressively reduced from oxide to metallic iron, and then further converted to iron carbide. Reduced pellets with high carbon content proceed to the next step of transformation at the temperature of about 700 degrees Celsius. Hot pellets are gravity fed at a constant flow rate into the arc furnace, where they are melted by the electric arc. The result is two top quality products: hot metal to produce all grades of pig iron or to feed a downstream steel plant, granulated inert slag for the construction sector or other industries. 100% of the processed CO2 is selectively sequestered for storage or commercial use. Water vapor is also emitted from the process and is recovered as a cooling fluid. IBLU is H2 ready. No modifications or upgrades are needed to the equipment. H2 can be added in the makeup gas at any time and at any ratio, maintaining the maximum efficiency. When using 30% H2 and 70% natural gas, the resulting pig iron product keeps a carbon content of at least 3.5%. IBLU also allows the use of 100% H2 as the makeup gas. In such a case, the process emission is only water, and the final metal product is liquid iron. IBLU technology exceeds the scale of millions of tons per unit. Fossil-free steel production is real. Tenova.com.
Thank you.
Thank you, sir. Thank you for the informative presentation. I once again request all the presenters to kindly adhere to the time limits. And for the next presentation, I invite Mr. Padampal, Chief of Blast Furnaces, Tata Steel, who's going to talk about decarbonization journey of Indian steel sector.
Good afternoon, everyone. Well, I'm going to talk about what is the outlook of India with respect to decarbonization and what Tata Steel quest is about the net zero. The topic is very, very emotionally because I'm going to share industrial practices which we are doing, which we have planned, and some larger scale is happening. But I understand the time paucity. I'll try to touch upon the real stuff. Background, we know, in the morning many speakers have talked about. This is about Tata Steel, and as we know that in India location, we are 21 million ton steel producer company, and we are targeting doubling the capacity by 2030. So our responsibility to be targeting the net zero and what all infrastructure challenges and changes will take place, that becomes very important. So, just to give the background, in the morning to just now, we talked about what is the role and what are the problem size for the decarbonization. If you see the left side of all three bars, what we are finding, coal-based DRI clubbed with EF or IF is having the maximum CO2 intensity emissions, and gas-based DRI is less. Presently, BOPOF, which is the most largest manufacturing unit across the India, that is having 2.46, and our target is to 1.1300 million ton per annum to be abated. If we continue producing like this by 2070, why? Because government has already declared we have to be net zero. So there are multiple approach. Something in the morning talked about process improvement, how we can improve the efficiency. Something through the carbon direct avoidance, and there is something about CCU or CCUS. We'll see how things are more important. These are the many things across the different steel industries. Initiative must be happening in sinter plant, how to use the waste heat. In the pellet plant, how to reduce the fuel rate. In the blast furnace, how we can maximize our 100% agglomerate, how we can have lowest fuel rate. Many different technologies. And the power plant, how we can produce more. Same with the steel making happening, how they can become the more efficient, how we can have the less energy requirement during the steel making. If you go ahead and just make a radar about all the initiatives and the problem, if you see the red dotted points, these are the initiatives in the left side in the chart, which is showing having the capacity of reducing the CO2 footprint less than 15%. If you see the blue chart, blue dots, this is having the potential reducing the CO2 footprint by 40 to 60%. And then there are some disruptive technologies, which is right side in the green dots, are having the potential of reducing greater than 80%. Okay. Now, how to match or how to go ahead? So, in the China also in the morning session we discussed about China is extensively doing the top gas recycling and the shaft injection. So that is the next shift. Either COG injection, hydrogen injection, DRI, or biomass, biochar, methylation. These are the next shift. We cannot live with this. Our task is much more. And if you talk about the retrofit, without eliminating the existing unit of steel production or iron production, by doing some changes, how we can maximize, like Hycroft, where the China is doing, Power Steel is doing, where not only they are injecting from the shaft, but they are also injecting from the bottom with the higher oxygen. That is actually the oxygen furnace, you can say, and getting almost 20-30% of CO2 reduction. So one small plant they have already built and they are going to scale it up. Similarly, the regiment, morning SMS colleague has already talked about, it has potential from the existing blast furnace. Today in the blast furnace we are using coke, sinter, PCI, many injections to reduce the fuel rate, but with no injection, no hot blast, how we can reduce the footprint by 50%, that is the technology. And there are something which we are also working on the disruptive technology, I will discuss. So just to give the glimpse, left and right, left is the BSP. If you talk about the all initiatives, process improvement, or RE energy, or top gas recycling, still there is left out. There are some 20%, 30% emissions to be abated. If we talk about right side, with all initiatives, still the green over, around 40 to 50% is still left out, which is saying that CCU or CCUS is inevitable. We have to think about it. And in Tata Steel, In broadly, in the two category, the carbon direct avoidance and carbon capture and utilization, we are working. One is the alternate fuel injection. For that, we have done extensive trial 1 month for cold wheel methane, because NG we know that it is not available for the Indian context, it's high cost. But CBN is the cheaper one. The biomass, biochar, many industries doing. Hydrogen, we have injected, we developed the know-how, hardware and software and related to process as well. And we are in the process of COG injection. So, we did it 2022 and it was a great success, but it has only potential of 5% reduction. That's the limiting factor. Hydrogen injection we did in a 1300 TPD operating furnace, but it has potential only 10% reduction. So that's the limitation. Then we have collaborated with SMS Polworth, and we are working how we can in the same blast furnace we can get more than 50% CO2 reduction. Yes, with RE part. That's the rider. Similarly, we are doing through our R&D 10 TPD municipal waste, through municipal waste hydrogen generation. That plant will be starting by December. So we will be solving the society problem also by utilizing the municipal waste and generating the hydrogen. Similarly, our lab, our R&D is also doing the chemical looping, where the iron oxide will be the catalyst, and a 2 reactor chamber. We will keep on, with the help of the steam, air and oxygen, we will produce hydrogen. That is the lab scale it is working, and we hope that we will be, next year we will be able to increase the capacity. The plan is in the bottom. And 115 tons per day hydrogen generation plant is also in the pipeline, and this is going to happen in next 2 years. That will be continuously injecting hydrogen to the blast furnace. That is what we are aiming. Something we talked about, CO2 we are already capturing, that is a very small scale, but the challenge is to scale it. We have collaborated with Carbon Clean. We have also collaborated with the Carbon Crate, where LT slag and the CO2, actually we are making the hexagonal block without cement. And but this has potential of consuming around 12,800 LD slags per ton per annum, and it can abate around 2,800 ton CO2 per annum. That is the capacity. The scrap everywhere is talking about, but as in the morning session, Professor said, after some time it is going to be also a scrap. But we are in line with all the steel industrialists who are trying to look about not only the short term, medium term, but the long term also. It's a mid term our plan. We have already 0.5 million ton scrap based electric arc furnace working, and one project is already going on in the Ludhiana 0.75, and our target is by 2030 2.5 million ton another plant of scrap based electric arc furnace, so that overall intensity of plant can be reduced upon. So this is about some initiatives which we are doing at Tata Steel. With the given time, I tried to cut short and try to give you the glimpse also what we are doing. Thank you. Any question? Yeah, please.
Sir, any update on iSarna technology under Tata Steel?
Yeah, so because of the time I didn't spoke about it. Tata Steel technology we are going to scale up. And right now it's a pilot, and by 1 million ton TPA we are going to scale up, and next year we are going to put this requirement. And in last 6 campaign we had very good insight, and like blast furnace stopping and starting, it's always used to be a big challenge. If you're putting down for a week, it becomes difficult, But in different campaigns we have learned the art of Hasarna. That's a very good learning we have captured, and we have planned to go for the 1 million ton. The basic design has already been in place, we are working upon to put this project in from the next year for getting the management sanction. Okay. Thank you. And that will be the technology for the inferior grade of iron ore. We cannot have Hasarna 11 million ton. We cannot have Hasarna 20 million tons. You will have very inferior grade of iron ore used over there. It will produce low phos, low silicon, and directly it will be a high product. You can use this product for making the high end automatic grade of steel. So from the inferior grade of iron ore. Thank you.
Thank you for the presentation, sir. The next presentation is going to be on the infrastructural applications of steel, like rails, transformer sheets, and high tensile plates, etc., for which we have Mr. Rajesh Ghosh, AGM TRL Kosaki.
Good afternoon to all. So I am Rajesh Ghosh from TRL Kosaki. So today I am going to explain the initiatives taken by a refractory company to reduce the carbon footprint, and also I will explain how we can optimize the RH degassing system so that the carbon footprint reduction can be done indirectly. So at first, why the RH degasser? RH degasser is an essential equipment that is for making the secondary steel making equipment, and it is key equipment for producing the infrastructure application steel like rail steel, transformer sheet, high tensile plate, etc. And as a technology provider, as I have explained, so I will explain how we can give a better RH vessel availability by improvement of performance and also our automation technology. And I will also cover up the initiative taken to reduce the carbon footprint in our site. So at first, the secondary steel making equipment RH degasser, I am going to give some brief introduction. So it is mainly used for removal of gaseous inclusions on the steel, and also it is used for adding some microalloys. And if you see the current production of the high tensile plate, IF grade steel, etc. So currently around 9.7 million ton of steel produced in India through RH route. And in year 28-29 it will be around 16 million ton of production. The forecast is like that. So to catalog this production, we need to improve the performance of the RH degasser unit, and also we have to also ensure that how we can reduce the downtime of the vessel. So here is the picture of the RH degasser units present all over India. So there are around 12 customers who are using the RH degasser unit, and within that 20 units are there, and 3 units are ongoing projects there, and TRL Kosaki is present in most of the customers. So here the star is the TRK, and the all other are the steel plant who are using the RH degasser unit. So we are in close vicinity. So if we see the performance of the TRK is currently holding the major business share in RH degasser unit, around 42% share is with TRL Kosaki. And what makes TRL Kosaki is the most preferable vendor for the steel industry is that we are using the technology from Japan, and through the technology transfer we are making in India all the products for the snorkel, vessel bridge, alloy chute, and coming material. So all the products are making in India. So apart from that, we are also holding the performance record in various customer sites like JSW Vijayanagara, SMS1, SMS2, RH2, JSW Dolby, that is 350 metric ton RH degasser. So during commission stage, we hold the world record of 63 hits, and also we are currently holding the benchmark performance in there. In Tata Steel Jamshedpur, we achieved 263 hits, that is the highest life in India. So apart from the India, we are also supplying our snorkels in abroad like British Steel and other customers, Tenova and all that. So actually we are supplying all the materials from India, so I am not going in details. Also we are mapping the damage factor of the snorkel, lower vessel, and how the damage factor affect the snorkel. We map the product and we design the product as per the damage factor of the snorkel. So focusing on the spalling resistance, evaporation resistance, HMR and structural stability. So apart from that, we also focus on the simulation part, how the simulation, by simulation we check out how it affects the snorkel performance. And through simulation we can find out that the outer castable damage pattern. So to accomplish this thing, we have developed a new gunning material for repair, focusing on the fast stickability, water demand, volume stability, low sinkage, high HMR. So this key property we have focused on and we developed our product. So this is the actual application of our product at various customer sites. So you can see the stickability of our product, and there is very minimum loss in this product. And also you can see that is the application in the inlet snorkel. So after gunning and after 1 week you can see the improvement in the snorkel scenario and how our product perform. So apart from that, now we are carrying the automation digitization to reduce the downtime of the RS vessel and improve the safety, installation and ergonomy. So at first I am showing the schedule lift arrangement which we have developed and we can go with the customer. Also we are now providing the fully automated RH gunning manipulator which is tailor-made for each and every customer. So it will reduce the downtime, fast and ergonomic solution, and we can control by remote, so it is very safe operation for the steel maker. And also it will reduce the time for processing of the steel. You can give some more time to process of the steel apart from the maintenance. So also we have some tailor-made solution for the pressure vessels like customized remote control. You can keep record of the material flow, water flow, and also you can control that. Also we have another solution that is with twin silo, so we can switch over from one material to another material very easily. So now I am showing a short video how animation that how this thing works apart from the manual thing. So only one person can control it through remote control, and it is the thing is actually pre-programmed, so we do not need to place the thing under the vessel and all that thing. So it will do the gunning automatically. So actually this kind of solution helps to reduce the downtime and also helps to reduce the carbon footprint indirectly for the steel plant maker. So now we are demonstrating our decarbonization initiatives and future readiness for our team. So as a TL course, we are also focusing on the sustainability and green infrastructure solution. So last year we have won the Environmental Excellence Award 2023, and from the QR code you can go through our website. So as a measure we have converted all our kiln to natural gas fired thermal unit, and this is the first Indian refractory company to do so. And with this we are committed to reduce our carbon footprint by 30% in year 2026-27. We have started our journey in 17-18. So from that we are going to reduce our carbon footprint. And it will not only help us to reduce the carbon footprint. With the gas firing, we will go for better temperature control, uniform firing, and overall quality improvement, and yield improvement is also there. So with that, I want to conclude that TL Kosaki is ready with new technology, not only from the technological point of view, also from the automation and decarbonization initiatives. And we are going to give the interchangeable snorkel, fast vessel exchange, comfy material for RH, all vulnerable snorkel, etc. And also we are improvising our iron gas purging system for cleaner steel, continuous product and design improvement, and enhanced production capacity to cater the demand of the steel maker. Thank you for giving us the opportunity.
Thank you for your presentation, sir, and thank you for adhering to the time limit. Let me invite the next speaker, Mr. Harsh Chaudhary, co-founder and CEO Centra World. He's going to talk about the role of technology and AI in decarbonization pathways.
Hello, good afternoon everybody. My name is Harsh Chaudhary, co-founder and CEO at Centra World. Is this going to come? Okay. Okay, good. While the presentation comes on screen, right, I think through the day we've had good engaging discussions with an esteemed group of panelists, right, talking about ways to reduce CO2 emissions. My presentation and my paper is more focused on the path before that, which is how to effectively measure and report your CO2 emissions, right, which is the precursor, because the simple pretext that what you cannot measure, you cannot manage. Now, quick numbers which I think all of you know, but the key message over here is that India's average CO2 intensity of crude steel is 2.5 tons of CO2 per ton of steel. The global average is 1.9. we need to reduce this by 30, 40, 50%, right? The whole point is how are you actually going to do that. While there is a need from a global citizen perspective, there is also a big business imperative over here. Now, steel manufacturers today are faced with four forces which are forcing them to decarbonize. And these are, call them forces, call them threats, or call them opportunities. The first one is coming from customer requirements. So what is happening is that, very steadily, there is a growing set of customers in construction, in automotive, in engineering, who main users of steel, who are coming around and saying that, hey, we need to use steel of lower CO2 intensity. And it's not just individuals who are doing this, but there are consortiums which are getting formed. For example, there's the First Movers Coalition or the Steel Zero. And there are many users of steel such as Volvo, such as SKF, who signed up and said that by 2030 we will buy steel only from players who are adhering to these standards, right? So that is pressure number one. Pressure number two are export regulations. Now, as everybody in this room knows, right, India is gunning a lot for increasing exports. Now, this EU has established this CBAM regulation, which requires reporting of CO2 footprint and reducing that. Else, there are going to be huge taxes. And one of the earlier presentations from JSW, we saw that the taxes may be equal to about $100 per ton of steel in the near future, so it's significant. Domestically also there are regulations coming. Many of you may be aware of the PAT scheme, which is more focused on energy efficiency. This is being remodeled into something called the CCTS, the Carbon Credit Trading Scheme in India, launched by the BEE under Ministry of Power. This will become effective by later this year, full enforcement by next financial year. This will also have a cost implication, right? And finally, capital markets, right? Many of you invest into stock markets, you're aware about how it works. There's capital financing happening. Companies with low CO2 emissions will benefit from lower interest rates. Now, these are all opportunities which are facing the steel industry. It's up to us to decide whether we're going to treat this as a threat or convert this into an opportunity. We at Centra World are focused on exactly that, on helping steel companies decarbonize. Our work is in measuring, calculating, reporting and helping companies reduce their CO2 emissions. We do this via a cloud-based software. We use AI, we use blockchain wherever necessary. Obviously, we are very, very focused on the steel sector and hence core sectoral knowledge there. We're about a 45-50 member team located in Bangalore. Our software is 100% made in India and we are working pretty much in these regions. A quick view, and I'll talk more about some of the concepts behind, but a quick view on our products, right? So the image that you see in the middle, that is really the software platform, cloud-based platform, access it from anywhere, any place. Some of the products here help you calculate your corporate carbon footprint, product carbon footprint, things which many companies do manually on Excel files are now, we're getting into the space where we can automate this entire thing. We can connect with the ERPs, SAP systems, etc., gather all of this data and put it into cohesive data reports. A lot of these now need to get certified externally. We have tied up with various certification agencies. They log in, certify the whole process. Through Centra.reduce, we provide very, very curated advice on which technology projects to follow, where should you install renewables, where should you not, what is the techno-commercial analysis of it and all of that, right? So a whole bunch of different products all cater towards helping steel companies manage and reduce their CO2 emissions. We're working with a bunch of steel companies in India and Middle East. Though we are only about a year and a half or 2 years old, we've had the good fortune of working with leading players. We're working with SAIL in Durgapur. We're working with Kalyani Steel. We're working with, close by here with Godavari Steel. We are working with a whole bunch of players in the Middle East as well. So, we've had good success because everybody is very curious about this topic, and the whole concept of measuring and calculating your emissions is still a little alien to people. Now, I'm going to go through a few use cases of what we find interesting applications, right? So, a lot of text on this slide, but follow what I'm saying, right? So now, let's say that you're a steel producer and you have a customer who's coming and saying that, hey, your CO2 intensity is, let's say, 2.5 tons of CO2. But they're saying, let's say it's about 3.5, and they're saying, hey, I'll buy product from you if it's at 2.5. Now you have two options at this point. Either you say, no, sorry, you cannot do, or you go back and invest huge capex, which will take a long time. These are the two options, but we come up with a third option. Now the third option is really that how can you reduce the emissions only of that particular customer order, right? You cannot change a production profile, you cannot change a production planning, but still how can you do it? So what we do is, we actually calculate emissions not at a company level, but on a heat by heat basis. So every heat of production which is happening on your SMS, we calculate emissions on that. We are able to link that back to each unique customer order. And for the customer orders where the customer is demanding a low CO2 footprint, we actually attach a carbon credit or a renewable energy credit. By doing this, you are avoiding huge capex and catering to the needs of niche customers. Now, this is not a long-term solution, but this is a short-term solution, a low capex solution to meet your immediate needs. This whole methodology has been certified by World Steel Association under chain of custody. We've implemented this at Emirates Steel in the Middle East. We've implemented this at Kalyani Steel, and shortly starting up at a few companies in India as well. Now, I'll talk about one more concept, right? There's a lot of trust deficit as far as value chain CO2 emissions go, right? People are really questioning that I know what my tier 1 supplier is doing, but I don't know what's happening before that. I have no clue where those emissions are coming from. That's why the whole concept of blockchain came around. We use it for cryptocurrency, etc. The same concept is applied to carbon emissions. This is something that we have also implemented, where we are able to track emissions on at each part of the value chain, where each value chain member is calculating the emissions and putting them on blockchain, which cannot be erased, it cannot be edited, nothing can be done with it. Once it's there, it's done, right? So nobody can fudge around with it. So the whole idea is that every member of the value chain calculates the emissions, puts it on a blockchain with a certificate, so that any person who's part of the value chain with the right access keys can access that data and get a good view on their CO2 emissions. This is foolproof, doesn't require third-party certifications, nothing. It is all based on technology. Right? Just one last thing that I'm going to leave you with is, in this world of sustainability, world of CO2 emissions, there's just a whole lot of stress which environment teams are going through as far as reporting goes. They're spending a lot of time, instead of helping themselves decarbonize, they're actually spending a lot of time reporting and writing out reports. This is where AI comes in. This is where Gen AI comes in. We are actually able to use a lot of this to automate our processes of measurement, reporting, etc. so that steel makers can get back to what they do best, which is making really, really good steel. I'm going to leave you with that thought. Thank you so much for your time, and we are present at the booth outside if you want to talk more about it. Thank you.
Thank you for a very engaging and compact presentation, sir. Next up, we are going to have a presentation on optimized gas cleaning for iron ore agglomeration, for which we have with us Mr. Satyaki Dasgupta, General Manager Sales, Primetal Technologies India Private Limited.
So I'm Satyaki Dasgupta. I'm in the environmental solutions business as a proposals manager. I'm going to stop. No? Again, stop. So we have diverse portfolios. In the morning we've been having all our steel makers. We have had Tata Steel, JSW, Nova, etc. And we also had Paul Wood, we had SMS, we had Daniel, etc. So from Primetals, we had a session in the morning for EHRC, and I'm only going to present one portfolio in our environmental solution business, which is known as Meros, and it's dedicatedly used in our sinter plants. But for the others, we're going to talk about. Okay. So the challenges in sintering are, of course, high quantities of dust, acidic gases, metallic and organic compounds. We all know that. We all have steel producers, steel makers here, and we know that, and we don't need to talk about it. But the solution that we are offering is basically Meros. It's a patented technology, one of its kind, and I guess it's the only of its kind in its market, which is essentially a series of successive treatment steps to remove acidic gases, dust, and metallic and organic components. We're talking about the benefits, but the major features are, of course, selection of additives, particulate removal up to 99%, you have DSOx up to 98%, And of course, removal of heavy metals, but it's not really measured. We have carried out pilot tests in several plants. This is a typical flow sheet, and I'm not going to take much time because I'm really short of time, so we are all short of time. So this is how it looks like. So we have this sinter plant. This is essentially the core part of our solution. We can also have the coking plant, log gases from a coking plant. We can also take it from a power plant, which we have done in our recent plant in Italy. And of course, pellet plant is of course another of our key portfolios. So after that, we do this additive injection with certain adsorbents, and based on the process which our client requires, it can be either slate lime, like calcium hydroxide, or it can be sodium bicarbonate. The advantage of sodium bicarbonate is of course that it is completely dry. We have a conditioning tower, which is essentially a reactor, and then for the particulate removal, we have a special kind of filter. I mean, it's essentially a pulse jet filter, but it's specially designed. We also have a denox option, but many of our Indian sinter producers, the sinter chemistry is not really, does not really economically warrant a denox process, but it's for customers outside India. Several of our customers outside India prefer this denox option as well. And we have a stack and a booster fan to provide the necessary draft. Of course, this is one topic which I shall be talking about in some detail, which is known as a leaching product, this byproduct leaching, which is essentially in order to reduce or reuse the dust which you are gathering, the residue which you are gathering from this entire process. Okay, so the major feature of this portfolio, of this Meros portfolio, is that it's modular, which means you may have an existing sinter plant, you may have an existing management approval of say certain budget, but you are compelled to reduce your emissions by such and such, and you may have certain management approvals for reducing say SOx, NOx, etc. after a certain amount of time, certain years. So all these can be modular. I mean, we can retrofit all these modules. We have additive injections, we have gas conditioning and desox, but this desox can be retrofitted. It's in a modular way. This polychlorinated dioxins, all these furans and heavy metals, etc. Of course, it's part of the desox, but we can select our additives accordingly. Back filter is basically our core design. Of course, I mean it's basically our base package, wherein it's just for reducing particulates. Now, in our recent installation, I guess it's commissioned in JSW Tornagalu, we have guaranteed a stack emission of something like 5 milligrams per novel meter. Or yeah, we can, or 10 milligrams I guess, but we can definitely go below that. Denox, of course, is an add-on package, but Indian manufacturers are not more interested in this. Removal efficiencies. Skip this slide because these are all experimental values and theoretical values. Usually plant manufacturers don't measure it, but this just goes to show that even with a standard desox module, we can have removal of VOCs and all the hydrochlorides, HFs, etc. by up to 99%. Okay, skip this slide again. It's just a portfolio, or one of the biggest Meros plants is installed in JFE Fukuyama, Japan. It was an off-gas volume of that sinter plant was roughly 8 lakh normal BTU. It was commissioned a few years back. And I'll talk about it in some detail. So this portfolio is close to 25 years old. Yeah. The first setup in India was in JSW Tornagalu, as we said, and the second setup is going on in JSW Dolby. I mean, it's going to be commissioned sometime in March next year. Erection is going on. We are in talks. We have a memorandum of understanding with SAIL Rourkela, and we are talking about it with them. And several other steel makers are, of course, showing interest in this portfolio. Okay, byproduct leaching is an interesting topic, wherein the challenge of the large quantities of byproduct which we are gathering from this entire sintering off-gas process to dispose that. And the solution is by leaching, which is essentially tailor-made. Okay. So this is a typical flow sheet which I am showing it again from a JFE plant in Japan, wherein we had a filtration step, we had a chemical treatment, we had a sedimentation, And this, because of the plant was located close to the sea, the treated water could be discharged to the sea. But elsewhere, if it's by a sludge or wherever, I mean, whatever regulations are imposed upon the steel manufacturers, this leaching process can be delayed. So of course, dust product without leaching plant and dust discharge with leaching plant, we have a lot of difference. Thank you so much, and thank you for I adhere to my time.
Thank you for a very informative yet crisp presentation, sir. Coming to the last presentation of this session, we have with us Mr. Kaushik Dasgupta from RHI Magnesita, who's going to talk about refractories as well as green steel.
Kaushik Dasgupta, working as Associated Vice President in RHI Magnesita in charge of metallurgical solutions and magnesia carbon research and development activities. So basically this is the CO2 generation by steel mill type. As we all know, the blast furnace BSP is primarily responsible for the catastrophe, 92% carbon dioxide generation, whereas EF minimals account for only 8%. So with the task of reducing this CO2 tonnage per ton of steel, when this Paris Agreement happened in 2015, the task is huge, from 1.8 to around 0.2, which is around 90%. So the lot of things need to be done. So now I will discuss the logistical challenges for integrated steel plants and DRI dilemma. There is always a dilemma. Which process is fruitful? See, an often highlighted carbon emissions reduction strategy is to shift from blast furnace to electric arc furnace production, but the two processes are not exactly direct substitutes, because in UF you don't have the metallic you don't have the metallic iron as such. You cannot use the iron ore directly, whereas in blast furnace you have the liberty of working with iron ore. And this, most importantly, an increased use of the EF process requires an increase in the supply of recycled scrap steel back into the system to enable the shorter and less carbon intensive process. So basically, this full decarbonization is possible by this electric arc furnace using scrap, then this increased usage of DRI in the UF, and the DRI plus EF using hydrogen. Which is Midrex as well as HYL DRI process, but these technologies are available at high cost. So in all probability, a conceptual process model that lies ahead of us is a large-scale green hydrogen-based DRI-EF steel production process, which has this smelter which will produce this carbon-free DRI that goes into the arc furnace. And then in the arc furnace, the input is this carbon-free DRI and the output is hot liquid steel and slag, and then we continue with the normal casting. Or it may well look like this also: DRI shut furnace, then submerged arc furnace and the BF route. Here we will be able to produce hot metal from this carbon-free DRI in the submerged arc furnace and then continue with the refining in the UF. So what is the implication of 0% using 0% carbon DRI or HBI? Primarily, mostly important is that you will be requiring more energy, because the temperature at which the steel melts increases with decreasing percentage carbon. This temperature will increase definitely. And thermodynamically speaking, when you talk about low carbon steel, you normally produce more FeO and in the slag, that calls for lower yields. And also there will be less available in situ chemical energy in the DRI because of almost no carbon. And other carbon sources will be needed for, because FeO DRI reduction foamy slag, all those parameters that has to be taken care of in any case if you want to produce steel in the year. Then you would be requiring a vigorous bath stirring. Because of less carbon, the churning of bath will be supposedly less, so you need artificial bath stirring from bottom. And all these will probably lead to more refractory wear because of longer melt times, then FU erosion of magnesia carbon bricks and carbon dissolution. And so we need to think or rethink about the refractory systems that goes into these steel making parameters. So this is because basically the refractory emissions in steel making overall carbon footprint. By 2030, we assume that steel plants will making good progress towards minimizing the carbon footprint. So in an indirect effect, the refractory carbon emissions will contribute to around 20 to 35% of the total carbon footprint of the steel industry. So the solution is to replace gas, oil with hydrogen when it comes to firing the refractories. And this is basically a heat flux within a hypothetical furnace which works with natural gas and hydrogen done by CFD simulation. The findings was that the more heat is going into the refractory walls of the furnace than into the product when firing hydrogen, thus raising the operation temperature of the refractory which accelerates corrosion and wear and requires more energy input into the process. Now some of the issues related to use of hydrogen as an alternative fuel. As we all know, this has a low heating value on a volumetric basis. So hydrogen being a light molecule with a high heating value on a mass basis but low heating value on a, so I need to have much more volume. So this fact leads to higher volumetric flow rates. And also hydrogen exhibits high flame temp speed and high adiabatic flame temperature. So I will always have a convection zone with less pressure than the radiation zone in the furnace. So things will be to some extent heavier in terms of energy exchange, temperature exchange. So this reduced pressure leads to reduced residence time of hot gases in the furnace radiation zone, sufficient heat exchange and excess heat in the furnace convection zone. This is about the kilns which will be used in firing. Also there will be a lot of NOx emissions and then this will have the tendency to form with aqueous solution and acidic compounds. So what strategies we have in place is substitute of natural gas with hydrogen to prevent CO2 in the off gas. So re-evaluation of the refractory lining of kilns and burner concept, we are already on that. And factory studies shows that silica is the most vulnerable to hydrogen reduction and MgO is the least, then alumina and most vulnerable is silica. So joint projects we are conducting with external academia and industrial partners, pilot projects based on research and development and capex, and of course recycling. So we are adapting our own processes and ensuring measures to control the emission level in the products, and we are every refractory specifications we have currently has its emission level mentioned in the product, and we are collaborating with the Austrian MCI Carbon to convert carbon emissions into commercial products, and will be by 2030 we will be forming an industry also in Austria. Then we are also exploring potential of using solar energy at our plant in Brazil. And also this is being done, this smelter technology development is being done with the Primetal Technologies in Europe. So basically this is we have a long-term expertise in NFM technology as a foundation for providing full support on DRI smelter process. So this is basically an electric furnace designed to melt and reduce direct reduction iron, DRI. So this means reducing carbon dioxide to 1/6 of the emission for the BF route, and most importantly it covers future demands of refractories. Also huge volume is required, 1500 to 3500 tons of refractories per submerged arc furnace. And from R&D point of view, what we are interested with right now is to develop some ultra low carbon magnesia carbon and reduce emission technology by forming new binder technology. and the reduction of the resin emissions by about 38%. Then zero emission, this is a new high temperature tempering technology we are working into, which will have no organic emissions and which will ensure same performance level as standard tempered bricks. And most importantly, eco-breach impregnation with reduced emissions. These are redesigned process for new impregnation results. The BAP content will be less than 0.1 ppm and the performance will be same as standard bleach. So in summary, challenges that lies ahead of us is R&D efforts need to make available new refractory grades for the change and the more demanding steel making process, understanding implications of the new process on refractory products, ability to supply and engineer all qualities of a DRI, smelter or EF, assist, and the opportunities lies in assisting both the OEMs and the steel product producers with the challenges of the new processes on the lining, transformation from traditional refractory supplier to a solution provider, and application of proven concepts and learnings of our industry into another industry. For example, use of long-term refractory expertise in non-ferrous industry as a foundation for smelting solutions. Thank you.
Thank you, sir. That was the last presentation of the session. I now request our session chairman, Shri Varinder Dhawan sir, ex-ED Operations Head, to kindly summarize briefly about all the key points that were discussed during the 6 presentations.
Very good afternoon to you all. Thanks to all of you post lunch session. Very attentively you listened to all the presentations. All the presentations were very informative. In today's discussion, we are all talking about CO2 reduction. And one of the major approaches that everybody is trying to adopt is improving the process efficiency. And second is use of renewable energy. These are the two areas where major effort has gone. In addition to this, a lot of efforts are being made in use of alternate technologies, use of hydrogen and other means for cutting down CO2 emissions. But these are all at a very nascent stage. And the cost part, especially the hydrogen cost and carbon capture cost, that is at present not allowing us to use these on commercial scale. At the end of the day, we have to understand that the product that we make after all these efforts has to be sold in the market. As far as market is concerned, in white good areas, cars and other things, customers may be ready to pay you higher price, but not in other areas. But CO2 has to be reduced because the climatic changes, the way they are taking, and the kind of commitment that the world has given, we may not get that much time. As we are experiencing every day, the climatic changes are taking very fast, and whatever the timelines that are set may not be valid in which we may see in times to come. So what is required is a very collaborative approach. Everybody is trying to do something or the other which may not be very helpful, because at the end of the day, if everyone doesn't do it, then the climatic changes will happen at their own rate. As we are understanding also, the targeted temperature rise that is not being met. So whatever efforts which are going in bits and pieces, until we have a collaborative approach, may not be very fruitful. So everybody tries to invent the hydrogen injection, say in blast furnace. If somebody does it, then it has to be copy paste, easily available. The technology should be easily available for others to use, so that they don't reinvent the wheel. Now what is happening is somebody is doing, then other companies are also trying to explore means of using it, which will not help us in meeting the timeline. Now coming to the today's presentations, the first presentation was by Denova Technologies. This DRI based they have talked about very interesting open slag bath furnace, which is a very interesting concept. But what they have not told is this must be based on natural gas, I understand. Any? But whatever this process, the slag rate is very critical. And how do we manage this slag rate? Because when you are using DRI, the slag volumes will be, when you convert it into final product, the slag rates are quite high. How do you manage those slag rates? Yeah. High carbon DRI, what is the carbon? Okay. Okay. Yes.
Yeah, basically what we are telling, the challenge first thing is to use low grade iron ore, low grade pellet, which is BF grade pellet. It is having high GAN, agreed. But if you are using this electric arc furnace, you need high amount of electricity, of course you need plugs and all to remove it, your productivity goes down. So what we are suggesting, why don't we melt it in open slag bath furnace? Remove the slag, the name is to remove the slag, we are not melting it. We are raising temperature only from 600 degrees centigrade, which we are getting hot here, right? We are melting it. Of course, it is a solder paste through which we are melting, just like submerged arc furnace. But in a brush arc mode, we are not smelting it, not in a submerged arc mode. And then we are removing the slag. Of course, we are adding it, but it works in a reduced atmosphere. We are removing the slag, and that slag can be used for the cement bridges, just like a blast furnace. And the pure pig iron can be utilized into the BOF, existing BOF. The same thing was not tried, it was the concept of Tata Steel Almudin, Netherlands. Earlier they were having the concept of high sulfur for last 20 years. Finally they landed up in buying HYL DRI plant, 0.5. Then they have opted for the rectangular furnace, what our RHI friend has shown. Then rectangular furnace has got a limitation. What we are offering is a typical submerged arc furnace, circular one. It occupies less space and more efficient. So that is the concept.
What are the slag volumes like?
Slag volume, you have to see what type of pellets are getting inside, and that we can calculate. I'll let you know.
Indian context. Actually, in the Indian context, that is the challenge. Using actually for the DRI used to have the pellet grade and a high grade of pellet for converting into the DRI. That's the biggest challenge in Indian context, which is being worked upon how we can introduce OBF. So again, the smelting, melt the DRI, take out the slag. That will remain a challenge for us, because then the reactor will not be the constraint of the DRI, but with the low grade of iron ore or pellet, we have to learn that art. Even in what you talked about Netherlands, the same philosophy they have. However, they have the very high grade of iron ore, but still pellet which will be converted into DRI is having less than 250 CCS, which is still a challenge. That's why they are also going for the smelting OBF. So just imagine what will happen in our condition. It's a part where we have to learn and unlock those issues.
And what about the cost of the metal they are producing?
See, not only Tata Steel, this same thing ArcelorMittal and many people they have worked out. And it is comparative to DRI electric arc furnace. and very less as compared to blast furnace, because it depends upon the situation to situation, as Mr. Padampal has mentioned rightly, that what is the coke rate, what is the coke cost, what are the other factors, but it is much more economical as compared to installing a complete blast furnace, sinter plant, coke oven. And the main important thing is that we are shifting from coal-based steel making to gas-based steel making, and it can also start with the coke oven gas, because actually what happened, I'll tell you regarding the coke oven gas. I'm just extending it. In July in 2015-16, we were just thinking, when Mr. S.S. Manti was there and Mr. Das Gupta used to be in head of this. At that time with Tenova, there was a plan to set up a gas-based, coke oven gas-based DRI plant here, so that DRI can be used into the existing blast furnace, so as to reduce the coke rate and increase the productivity. But of course that never matured. And this Chinese Bao Steel as well as HBI, they have implemented coke oven gas based 100%, and they are making their DRI out of it, and they are using it for various purposes.
Cost of the gas. And the next.
Price is electrode price, how much per kg, per ton of pig iron, how much kg of the graphite electrode?
Here we are not using graphite electrode. Here we are using the Samaja furnaces, what they use for ferrochrome, the Soderberg paste. That is 1/10 the price of the graphite electrode, and the consumption is around 2.5 to 3 kg per ton of pig iron.
And the second paper was presented by Tata Steel, very informative paper, and they have talked about many efforts they are made, especially use of DRI, hydrogen injection, coke oven gas injection, and use of biomass for CO2 reduction. And finishing mills also, a lot of effort has been made. In the morning also we talked about it, from liquid steel to HR coil, and cutting down the reheating furnaces. That is a major step in CO2 reduction, which is being implemented by many of the players. Hydrogen injection and high Sarna, this also seems to be an interesting technology which can be helpful in Indian context, especially we have plenty of low grade iron ore, 45-50%, which is lying unutilized. It can help us in consuming that and also reducing CO2. So effort needs to be made in this direction. Then we had presentation by TRL Korasaki. They are using natural gas for making manufacturing of refractories for CO2 reduction. But in Indian context, the cost of the natural gas and its availability, that is a restricting factor which needs to be seen. And the fourth paper was the role of technology and AI. For CO2 reporting, especially this is more relevant in today's context when in 2026 carbon-based taxing will come into force, and the reporting will be very critical. So they have this is an excellent area in which they are working, which will be very helpful for Indian players in reporting the CO2 emissions. Fifth was optimized gas cleaning by prime metals. This Miros technology is also well established, and I think Jindal are already using it, and other players or new establishment that is coming, they are also going for it. It is basically increasing the process efficiency. And the last was a paper by RHI Magnesita. We are all talking about the use of hydrogen for reduction. The impact it will have on the refractories, that is being well anticipated by them, and they are working on it. In the end, I would say, sum up by saying that we need to have a more collaborative approach. Let's not do things in bits and parts, because that will not help actually. If we have to meet the timeline, then whatever good thing has been done by one agency, maybe we can have a joint group sort of thing, so that one good thing can be replicated in other plants, in other industries, so that the time is cut short. Thank you all for your attention.
Thank you for a very insightful summary, sir. I think sir has captured all the key points and has made a very insightful summary. We also thank all the presenters for their time and effort in making these presentations quite engaging, informative as well as compact, and for trying to stick to the time limits. That must be quite a challenge, I guess. Thank you everyone, and as a token of our gratitude, we have some mementos for all the presenters, for which I request Shri Varendra Dhawan sir to kindly present these mementos to all the presenters. Mr. M. Praveen Chaturvedi sir, Senior VP, Telugu Technologies Private Limited. Mr. Padan Bal, Chief of Blast Furnaces, Tata Steel. Mr. Rajesh Ghosh, AGM, TRL Prosaki. Mr. Satyaki Das Gupta, General Manager, Primetals Technologies, India. Mr. Kaushik Das Gupta, RHI Magnesita. I request Dhawan sir to kindly present a memento to our reputed Yogesh Shastri sir. Sorry, you need to present a memento to Dhawan sir. I request Bonia Mukherjee ma'am, GNAMD, to present a memento to our rapporteur Yogesh Shastri sir. Thank you, ma'am.
Don't forget to like, subscribe and share the videos.